In today's lesson, we'll be learning about Pythagorean Theorem. In a previous lesson, we learned that Pythagorean Theorem describes the relationship between the sides of a right triangle. In other words, a squared plus b squared equals c squared, where a represents the length of a leg, b represents the length of another leg, and c represents the length of a hypotenuse. Take a minute to think about the typical operations in math. Now, I want you to think of their opposite operations. The opposite of addition is subtraction. The opposite of subtraction is addition. The opposite of multiplication is division. The opposite of division is multiplication. The opposite of an exponent is something called a root. We know this as a square root currently. Specifically, I want you to keep this in mind today. In our first example, we have a right triangle. The hypotenuse is unknown. This leg is 4 centimeters long, while this leg is 5 centimeters long. Before doing any calculations, let's make an estimate of the length of the hypotenuse. Remember, the hypotenuse is the largest side, which means it must be greater than 5 and 4. I'm going to estimate it to be about 6 centimeters, since it looks a little bit larger than this leg. Take a look at this equation. A represents the length of a leg. We know one of the legs is 4 centimeters. I'm going to replace A with the number 4. The exponent of 2 stays the same. Next, B represents the length of another leg. We know the length of the other leg is 5 centimeters. So I'm going to replace B with the number 5. The exponent of 2 will stay the same. Last, C represents the length of the hypotenuse. We don't know the length of the hypotenuse. In fact, that is what we're looking for. So that C is going to stay the same, and the exponent of 2 will also stay the same. 4 to the power of 2 is the same thing as 4 times 4, which is equal to 16. 5 to the power of 2 is the same thing as 5 times 5, which is equal to 25. We can't really do anything with c to the power of 2, so that's going to stay the same. We can simplify this by doing 16 plus 25, which is equal to 41. Again, we can't really do anything with c to the power of 2, so that is going to stay the same again. Something doesn't look right. We're getting 41, but our estimate was around 6 centimeters. There's no way this hypotenuse can be 41 centimeters long. Therefore, there's something we need to do. If you take a look at c, it is being raised to the exponent of 2. Remember, the opposite of an exponent is a square root. So what I'm going to do is I'm going to square root this. And there's a saying I like to use. What you do to one side of an equation, you must do to the other side of the equation, which means I'm going to take the square root of 41 as well. Now, because a square root and an exponent of 2 are opposites, they're going to cancel out, which leaves the letter C all by itself. Next, we can take the square root of 41, and that is going to give us approximately 6.4. We estimated the length of the hypotenuse to be about 6 centimeters. Through our calculations, we determined the hypotenuse to be about 6.4 centimeters, which is pretty close to our estimate. In our second example, we have a right triangle. The length of the hypotenuse is unknown. The length of this leg is 10 centimeters, while the length of the other leg is also 10 centimeters. Before doing any calculations, let's make an estimate of the length of the hypotenuse. Remember, the hypotenuse is the longest side. Therefore, it must be greater than 10 centimeters. Since it looks a little bit longer than the other legs, I'm going to estimate it to be about 15 centimeters long. Take a look at this equation. A represents the length of a leg. We know the length of this leg to be 10 centimeters. Therefore, I'm going to replace a with the number 10. The exponent of 2 will stay the same. Next, b represents the length of another leg. This other leg has a length of 10 centimeters. Therefore, I'm going to replace b with the number 10. The exponent of 2 will stay the same. And last, c represents the length of the hypotenuse. We don't know the length of the hypotenuse. It's unknown. In fact, that is what we're looking for. So that letter c to the power of 2 is going to stay the same. 10 to the power of 2 is the same thing as 10 times 10, which is equal to 100. Again, 10 to the power of 2 is the same thing as 10 times 10, which is equal to 100. And c to the power of 2, we can't do anything with that right now, so we're going to let it stay the same. We can simplify 100 plus 100, which is equal to 200. Again, the c to the power of 2 is going to stay the same. Something looks off here. This 200 is very different from our estimate of about 15 centimeters. There is no way this hypotenuse can be 200 centimeters long, so there's something we still need to do. I want you to take a look at c. It is being raised to the exponent of 2. If you recall, the opposite of an exponent is a square root. So I'm going to write a square root over this. There's a saying I like to say, what you do to one side, you must do to the other. So if I'm going to square root the right side of the equation, I'm going to have to put a square root on the left side of the equation over the 200. Since the square root and the exponent of 2 are opposites, they're going to cancel out, which means that c is going to be left all alone. Next, using a calculator, you can find the square root of 200, and you should get approximately 14.1. Remember, we estimated the length of the hypotenuse to be about 15 centimeters. Through our calculations, we discovered the hypotenuse to be about 14.1 centimeters, which was pretty close to our estimate.